In this section, you will learn how to use wave equation y equals to a sine wt minus ks to solve simple problem. See you there. Good morning, student. In this session, we are going to be looking at solving simple problem based on wave equation. If you have any area of difficulty, don't forget to state it in the comment section. Also, don't forget to subscribe this channel and click the notification button for fresh videos when they come up in the next session. So let's start with this example on the board. Now, in the example given on equations of motion based on the previous sessions, here we have that the equation y equal to 5 sine bracket over 4t minus 3x bracket close, where y is in millimeters, s is in meters, and t is in seconds, represent a wave motion. We are asked to determine number 1, amplitude of the wave, number 2, frequency f, number 3, period t, and number 4, speed of the wave v, and number 5, wavelength lambda. Now let's solve this problem. Now, from our previous section, we have that y is equal to a sine wt minus kx. So we can use one of these equations which matches this. Now, by simple comparison, we can continue to solve this problem. Now, we are asked to find number 1, the amplitude A. So amplitude A. Now, before we begin to solve for amplitude, remember we are given expressions. Here, we are told that where y is in millimeters and s is what in meters. So we have to equate the units. And t is in seconds represents a wave motion. Here, recall that the amplitude is along the vertical y and horizontal is x. So that's amplitude what? A. Amplitude what? A. So we have the amplitude A along the vertical. So amplitude is the maximum displacement from the horizontal position 0. So therefore, we can then compare. By simple comparison, we have that A is equal to 5. So A is equal to what? 5. Remember, we are told that where y is in millimeter. So that because A is equal to what? 5 millimeter. But by standard unit, the amplitude is measured in meter. Therefore, that A is equal to what? 5 over 1000. And that gives you what? 0.05 meter. So that becomes our amplitude. So that's the answer. So we go to number 2. Number 2, we are asked to solve for frequency. Now, before we solve for frequency, first of all, study the equation. Now, when you study the equation, you observe that there is no f in the equation. There is no f in the equation. We are asked to solve for frequency. No f. So therefore, there is need for us to look at again some basic formulas. So I'll write here. So one of the basic formula here. Number 1, we have W equal to 2 pi f. Then 2 is a K is equal to W over V. Then number 3 is that V equal to lambda f. And number 4, here we have that f is equal to 1 over t. And number 5, we have t is equal to 1 over f. Well, with this basic formula, let's see how far we go with this equation. We are asked to solve for frequency f. Now, solving for frequency f, so we see that there's a property here, a parameter w, which equals to 2 pi f. So we write w is equal to 2 pi f. So we go straight to the equation, we discover that W can be compared to 4t. Wt is equal to what? 40. So we then write Wt is equal to what? 4t. So we can make W the subject of the formula. That means W is equal to 4t over t. Or you can say, we can write it this way. Let's do it in a very simple way. W divide both sides by what? We divide both sides by t. W t over t is equal to what? 4t over t. So t will cancel, t will cancel, so you are left with W equals to what? 4. So we're gotten our 4. Then the next thing we do now, we have obtained W. Remember, we are interested in what? F. So since we've gotten W to be what? 4, in place of W, here we write 4 is equal to what? 2 pi f. So I'm going to share this board into 2 now. I can complete. 4 equals what? 2 pi f. Since I'm interested in f, so I'll divide both sides by 2 pi. So I have 4 over 2 pi is equal to 2 pi f over 2 pi. 2 pi, we cancel 2 pi, we are left with f. So we are now left with f equals to 4 over 2 pi. And again, 2 we cancel, itself is 1, 2 into 4 is 1, 2. So that gives us 2 over pi. 2 over pi. So f is equal to 2 over pi, which states as well 2 over 3.142. Remember, pi is a mathematical constant. Pi is equal to 3.142. So it's a mathematical constant. So 2 divided by 3.142. So what will that give us? So that will give us 0.637. So our f is equal to what? 0.637 hertz. So we have succeeded in solving for f, which was our frequency. So we have succeeded in solving for f, which was our frequency. So number 3 says that we should what? Solve for period. First of all, period t. Then how do we solve for period t? How do we solve for period t? In solving for period t, we come back here. So let's use our, so period t, we have t is equal to what? 1 over f. Now so far, we have had that f is equal to 0.637. That this was t is equal to 1 over 0.637. Equal to 1 over 0.637. So when you do that division, so our t is equal to 1.569. 1.569 seconds. So that's our what? Our t. So the next question, we are asked to solve for speed of the wave v. Speed of the wave v. Again, we go back to our equations. Now, when you look at the equation, you observe that there is no v in our equation. But you have to look for a property that is connected to what? To v. How do you do that? You go back to your simple formulas. Simple what formula? We have here k is equal to w over v, where k is wave number or wave constant, w is what? Angular velocity, and v is linear velocity. So in other words, we can have here, since k is directly in the formula, we can have k is equal to what? W over what? V. K is equal to what? W over V. So we solve for k. We solve for what? K. Now because already we have W equals to what? 4 from the previous expression. We have here that W is what? W is equal to what? 4. So if W is equal to 4, then we can then see that we don't have the value for V. So we don't have V. We don't have V yet, and we are solving for what? V. Speed of the wave. Speed of the wave. Speed of the wave. So let's write it. Let's write it. Speed of wave V. And that's number 4. And that's number 4. And that's number 4. So again, we said that what K is equal to W over what V. K is equal to what? K is equal to W over what V. I already have W equals to what? 4 from our previous solution. Then, but we don't have V. V is what we are looking for. So let's write K first. So we don't have K, we don't have what? V. But we can solve for K from this equation. We can solve for K from this equation. So we can solve for what? K. So how do we solve for K? By simple comparison. So again, we compare in this equation. So when we compare this equation, we see that Kx, here, our Kx is equal to 3x. So Kx is equal to 3x. So divide both sides by Kx over n, and x equal to 3x over x. So x will cancel s. So I have k is equal to what? 3. So we've gotten the value for k. So now I have k equals to 3, w equals to what? 4. So we can then solve for what? V. So we can then solve for what? V. So we can then solve for what? V. So we can then have that from k equal to w over what? V. So we have 4, k is 3 now. 3 is equal to 4 over what? V. So when we cross multiply, we have 3 times V. You have 3V is equal to what? 4 times 1 is what? 4. So we divide both sides by 3. 3V over 3 is equal to 4 over 3. So 3 will cancel 3, you are left what? V equals to what? 4 over 3. So therefore, our V will now be what? 1.33 meter per second. So we have succeeded in solving for what? Our V. We have succeeded in solving for what? Our V. So the last one is what? Wavelength lambda. So the last one is what? Wavelength lambda. So I'm going to solve for our wavelength lambda. So for us to do that, so we need to clean this part of the board. So let's clean this part of the board. And we will solve for our wavelength lambda. So again, for us to solve for lambda, wavelength lambda, that's number 5. Number 5, wavelength lambda. So that's number 5. Now, in the equation, lambda is not directly represented. Lambda is not directly represented. So what do? We go to our simple formulas. We listed them, 5 of them. So we can use the one that is directly related to what? Lambda. So there we have V is equal to lambda F. Here F is frequency, line wavelength, and V is what? Velocity or wave velocity. So we leave the parameter R. So we have solved for V. V from what we have solved is what? 1.33 meter per second. And F we have solved for is what? 0.637 X. And so again, we're interested in lambda. Weak lambda is the formula. V equals to lambda F. By dividing both sides by Vf equal to lambda F over F. So F will resolve, shall be left to lambda equals to V all over what? F. So we substitute the parameters. We have V is what? 1.33 over f. F is what? 0.637. So our lambda is being by. So when you divide the numerator by the denominator, 1.23 divided by 0.637. So our value becomes for 2.09. 2.09 meter. 2.09 meter. So we have succeeded in solving for amplitude, frequency, period, speed v, and wavelength lambda. So with this, we come to the end of this section. Now listen, when you're having any difficulty, don't forget to state it in the comment section. Don't forget to state it in the comment section. And also, don't forget to click your subscribe button and the notification button for other videos in this session. In the lesson ahead, please be prepared to leave in the comment section questions and state area of difficulty. Looking forward to see you there.